All right, so now we're moving on to the second video of section 2.3, and this one is going to be specifically about ogives. All right, so that's the one that we're going to focus on in this video. We already did histograms and frequency polygons, and we're going to do ogives today. All right, remember, the essential question, something we need to be focusing on throughout the entire section, unit, everything for this, for what we want to be focusing on while we're learning this, is how can we present data better? How do we know what graph to use? And how are different graphs more useful than others? All right, so just like before with the histograms and frequency polygons, we are going to use the table that we created in section 2.2 for the record highs for each state in the U.S., and we're going to use this now to graph our ogive. All right, when we create our ogive, we're going to start setting up our table just like we would have for our histogram. Meaning that the tick marks that we're going to use along our x-axis is going to be our class boundary. So we'll start with 99.9, 99.5, and then we're going to have to make a tick mark for every single one of the rest of our class boundaries. So I'm going to go ahead and do that now. All right, so I went ahead and filled in the rest of our x-axis with all of our class boundaries from 99.5 all the way to 134.5. Remember, this is measuring our temperature, so that's why I gave each of those a degree sign. Now, the main difference between an ogive and any of the ones that we've done so far is before we were doing frequency, but now the ogive does the cumulative frequency. So it's what's been adding up for each of our class limits as we go. So that's why we need to create that cumulative frequency. And we know that we have 50 states. So we're just going to count by fives here. So this will be 5, 10, and I'm going to keep going. All right, I had to put these in green just so you can see the difference. I know it's very bunched up here, but I just don't have that much space. You want a piece of paper, obviously we'll have more space to make sure you write this out a little bit neater. All right, so now the way that we do this is we mark the cumulative frequency at the upper class boundary for every single class limit. So for instance, this 2, that's our first cumulative frequency because there's no number that we can add it to. So this 2 will be marked here at this 104.5. So here's our 2. We had 2 plus 8, so that's 10. So that 10 will go at the upper boundary of this second class boundary. So that would be at this 10. We have 10 plus 18, so that's 28. So 28 will go at the upper class boundary here. Plus 13, so that'll be 41. So that 41 will go at this upper class boundary over here. Plus 7, so that's 48, so that will be over here. And then it'll be plus 1 and plus 1. All right, just like we did for our frequency polygon, we're going to then connect all of these with line segments. And then the difference is, before with our frequency polygon, we had to go ahead and draw this endpoint back down to our x-axis. We do not do that here, but we do draw this one down to the beginning of our first class boundary because we started out at 0 there. So that's why we got to make sure that we draw this line down to our x-axis at the beginning of our first class boundary. And this one doesn't get drawn down because then we're saying that our frequency then goes back down to 0. So as we're going along, we're then adding the amount that we have. So this allows for us to look at this in a few different ways. One, we can see how quickly maybe it jumped from point to point. Where was our steepest jump? We can do that by taking the slope of each of these points. And we can just look and see how quickly things are happening amongst other things as well. But it's just another way for us to visualize the data. All right, that is it for this video.